Today we're going to go over the two special right triangles. The first special right triangle is a 45 degree, 45 degree, 90 triangle. In a 45 degree, 45 degree, 90 triangle, two of the angles are the same, which means that two of the sides are also going to be the same. We have an isosceles right triangle. If this side is x long, this side is also x long, and our hypotenuse is longer than either leg. How much longer? Well, it turns out that the hypotenuse is exactly the square root of 2 times longer than the leg. Our second special right triangle is a 30 degree, 60 degree, 90 degree triangle. It has 3 different angles, so all 3 sides are going to be different lengths. The shortest side I'm going to label x. Our longest side is going to be the hypotenuse across from our 90 degree angle, and it's going to be twice as long as our shortest side. And our middle side is across from our middle angle, across from our 60 degree angle, is going to be longer than our shortest side, but shorter than our longest side. It's going to be right in the middle. So we're going to take our shortest side and we're going to multiply it by a number that has to be greater than 1 and less than 2. It turns out that that length is exactly the square root of 3. If we take these two concepts and apply them to our examples, in example 1, we have a 45 degree, 45 degree, 90 triangle. The two 45 degree angles tell me that I have 2 congruent sides. So side M is going to be 3. And side N, which is our hypotenuse, is going to be longer. How much longer? Well, it's going to be the square root of 2 times longer. Our second example is not drawn to scale. I always like to redraw these triangles to scale and orient them so they are like our examples. The hypotenuse in this case is 5 square roots of 2. Across from our 45 degree angle is n, and across from our other 45 degree angle is m. If we look at our hypotenuse, it's 5 times the square root of 2, which means that each leg has to be 5 if we follow our pattern. In example 3, our triangle is drawn to scale, but it's just oriented different than our example. I'm going to redraw this triangle so it's oriented like our pattern. Our hypotenuse is across from the 90 degree angle, and in this case is n. Across from our 30 degree angle is 13, and across from our 60 degree angle is m. So if we follow our pattern, we know the shortest side. We know the x side. To get to our hypotenuse, we're going to double our shortest side. To get to our middle side, we're going to take our shortest side and multiply by the square root of 3. In example 4, our triangle is not drawn to scale. So redraw that triangle to scale. Across from the 90 degree angle is 22. Across from our 30 degree angle is m. And across from our 60 degree angle is n. In this case, we know the hypotenuse. So if we go to our example, we know this side. To go from our hypotenuse to the shortest side, we need to divide by 2. So m in this case is half of 22, 11. Now we know our shortest side, and to get to our middle side, we're going to take our shortest side and multiply by the square root of 3. In a 45, 45, 90 triangle, each leg is the same length, and the hypotenuse is the square root of 2 times longer than the leg. In a 30, 60, 90 triangle, if the shortest side is x, the hypotenuse, the longest side, is 2 times x, and the middle side is the square root of 3 times longer than the shortest side. Today we're going to look at some triangles that use these two formulas, but in order to get the answer, we need to apply our algebra skills. In example 1, the two legs of the triangle are the same length, so m is the square root of 10 long. The hypotenuse, n, is longer than these two legs. How much longer? Well, it's the square root of 2 times longer. So I'm going to take the square root of 10 and multiply it by the square root of 2. Now this is where we need to apply our algebra skills. The square root of 10 times the square root of 2 can be rewritten as the square root of 10 times 2, all underneath one square root symbol. We can then do that math. 2 times 10 is 20. And now we need to simplify the square root of 20. 20 is divisible by 4. 4 is a perfect square. I can then distribute that square root to the 4 and to the 5. The square root of 4 is 2, so my final answer for n, the hypotenuse, is 2 square roots of 5. I'm still applying the 45, 45, 90 rules. I'm just using some algebra to simplify my answer. Example number 2. The triangle is not drawn to scale, so I'm going to redraw the triangle to scale. The hypotenuse in example number 2 is 4, and each leg is n and m long. In this example, we know the length of the hypotenuse. If we knew the length of the leg, we could just multiply that length by the square root of 2 to get the hypotenuse. Now we're going to go the other way. We actually know the hypotenuse, and we need to figure out the leg. So to go from the hypotenuse to the leg, instead of multiplying by the square root of 2, we're going to divide by the square root of 2. So to go from the hypotenuse to the leg n, we're going to take 4 and divide it by the square root of 2. Again, this is where we need to apply our algebra skills. We can never have a square root in the denominator, so we need to rationalize the denominator. To rationalize the denominator, I'm going to multiply by the square root of 2 over the square root of 2. Multiplying those two fractions together, I end up with 4 square roots of 2 over the square root of 2 times the square root of 2. And I can simplify the square root of 2 times the square root of 2 underneath one square root symbol, which turns into the square root of 4. And what's nice about the square root of 4 is it's a perfect square. The square root of 4 is 2. Finally, I need to divide this 4 and this 2. They're both outside of the square root symbols, and 4 and 2 are both even, so I can simplify them. My final answer is n equals 2 square roots of 2. If n is 2 square roots of 2, m also has to be 2 square roots of 2, since they're both the same length. Example number 3. This triangle is drawn to scale, but I'm just going to rotate it so it lines up with my first example of a 30, 60, 90 triangle. Here's my 60 degrees, here's my 30 degrees. My hypotenuse is n. My shortest side across from the 30-degree angle is the square root of 15 long, and my middle side across from the 60-degree angle is m. In this case, I know the shortest side. So to go from the shortest side to the longest side, I need to multiply by 2. So n is going to equal the square root of 15 times 2. To simplify the square root of 15 times 2, I'm just going to rewrite it as 2 times the square root of 15. To go from the shortest side to the middle side, I need to multiply by the square root of 3. M is going to equal the square root of 15 times the square root of 3. If you notice, I have 2 square roots being multiplied together. I can simplify the square root of 15 times the square root of 3. Different than 2 times the square root of 15, where 2 is just an integer and the square root of 15 is irrational. I can combine these two underneath one square root symbol. 15 times 3 is 45. And now I need to simplify the square root of 45. 45 is divisible by 9, and 9 is a perfect square. I can distribute that square root to the 9 and to the 5. And my final answer is 3 square roots of 5. My last example, example 4. My triangle's not drawn to scale. It doesn't look very nice, so I'm going to redraw it to scale. My hypotenuse is the square root of 15. The shortest side is m, and the middle side is n. Now I know the hypotenuse. So if I look at my formula, I'm right here. If I knew the shortest side to get to the hypotenuse, I'd multiply by 2. To go the other way, to go from the longest side to the shortest side, I'm going to divide by 2. The square root of 15 divided by 2. Now 2 is just an integer. I don't need to rationalize my denominator. The square root of 15 can't be simplified, so this is as far as I can go. To figure out n, my middle side, I need to take my shortest side and multiply by the square root of 3. So n is going to equal the square root of 15 over 2 times the square root of 3. Now in order to multiply by the square root of 3, the square root of 15 over 2 is a fraction. I need to turn the square root of 3 into a fraction. Now I can multiply straight across. The square root of 15 times the square root of 3 over 2 times 1, which turns into the square root of 15 times 3 over 2. Which turns into the square root of 45 over 2. And I just simplified the square root of 45 over here. The square root of 45 is 3 square roots of 5 over 2. 3 and 2 can't be simplified. 5 can't be simplified with anything because it's underneath the square root symbol. So that's my final answer. N equals 3 square roots of 5 over 2.